Hello, I'm Ted Dangelmeyer with Dangelmeyer Associates, and this demonstration is about the coupling coefficients of charge related to circuit boards. As you can see in the sketch behind me, we have a circuit board that is positioned next to and perpendicular to a static generating material. Here it's parallel to the circuit board, and down here it's perpendicular to the circuit board. There's an effective capacitive coupling between those two different orientations. So my question to you is, which is a stronger correlation? Well, if you look at the results, you'll see that the parallel orientation is almost a one-to-one relationship. So if this is charged to 5,000 volts, it's likely to induce close to 5,000 volts on the board, whereas the perpendicular orientation would be approximately half of that value. Sometimes having this knowledge is valuable when you have to do engineering estimates of the risk that you might be exposed to related to circuit boards and static generators. Now, if we want to demonstrate that, what we can do is to take this field meter with this charge plate monitor attached. This is simply a metal plate that is floating. This top plate is isolated from ground, in other words, and enables us to measure the response of the field that would induce into this plate. So for this demonstration, what I'd like you to do is to imagine that this plate is your circuit board, and then here is a static generator perhaps in your manufacturing process, and you're trying to assess the risk. I'm going to turn on the data, and I'm going to charge this insulator and place it on the plate. Now you see from the response here that we're getting, in this case, it's about 750 volts when it's parallel. If I take it off, it goes back to 0, and then as I bring in the perpendicular orientation, it's about half that value. And you can see it's pretty repeatable. Now it's parallel, here it's perpendicular, and it's just about half the value. Again, it's not, it's good information to have and to help assess the risk of various scenarios that you might run into in the manufacturing operation or elsewhere, of course. Ionization may be the answer. Often with static generators, that is the remedy or the proper solution. But regardless, it's good to be able to make these approximations. And that concludes this demonstration. Thank you.